Hello and welcome back to another episode of Math with Sohn. Today we're going to be doing some reflecting of shapes on an XY coordinate plane. Let's get into it. So given the graph, we're going to be able to reflect it across whatever line they tell us. So in this first one, it is reflecting across y equals -2. So I'm going to draw a horizontal line on the y-axis at -2. That is that dotted line that I am drawing right now. And I'm going to reflect this image over it. So I'm going to flip it over this line, and this image is going to flop up over to here. So the way we're going to do that is by just counting how far we would have to go. So if we went up by 2 from point Q, up by 1, 2, I go up by 2 more, and that would be my point Q prime because it is the new reflected shape. And this one I'm assuming is a Z. I went up by 1, 2, 3 from here. I'd go up by 1, 2, 3 to get my Z prime. For point E, I went up by 1. I'd go up by 1 more to get my E prime. Now this I didn't move at all, so I'm not going to move at all. It didn't go up or down by anything. I'm not going to go up or down by anything. When I connect my dots, I have my new image. The next problem is going to reflect across the x-axis. The x-axis is this one right here. So I'm going to put a big dotted line here, as aggressive as I can make it, so we can see it. And then we just count how far do we go down? Go down by that same amount. We went down by 1, 2, 3 from point A, so I go down by 1, 2, 3, and I label it A prime. For point D, we went down by 1, 2, 3, 4, 5. I go down by 1, 2, 3, 4, 5, and I label it D prime. Point M, I went down by 5. I go down by 5 more. Point W, I went down by 4. I go down by 4 more. And I connect the dots by tracing it out, and I should have the same shape that we did last time. Make sure we label it M prime, W prime, and D prime. Now the next two are going to be a little bit different because they're going to be reflecting across, well, the next one is going to be a little bit different. It's going to be reflecting across y equals -x. So y equals -x has a slope of 1 and a y-intercept of 0. If I drew that line right here, our shape is going to need to flip over that, which is going to be a little bit more difficult because it's not going to be just straight up or down or left and right. It's going to be a diagonal distance, and sometimes the diagonal just doesn't work, okay? So if you have this situation, you might be able to count the diagonal distance and be like, oh, we went a diagonal distance of 1. We can go a diagonal distance of 1 more. But occasionally that's going to be really difficult to do. So what I would like you to do is label these points literally by like what they are. 1, 2, 3, 4, comma 2 is point S. And point A, we already did, was 1, 2, 3, comma -1. 3, comma -1. A. Point T is at 1, 2, 3, 4, 5, comma 2, -2. And point J is at 4, -1, 2, 3. If it is reflected across y equals x, we will end up switching the signs. So my S prime is going to be the flipping of these 2, comma 4. That's if you're reflecting across y equals x. But this is not just y equals x, this is y equals -x. So because it's y equals -x, I'm not just going to switch these, I am also going to switch the signs of both of them. So you switch the x and y, and you switch the signs when you're reflecting across y equals -x. Y equals regular x, we just switch the signs, or we just switch the x and y. So for my A prime, I'm going to switch these two, -1, and 3, and because it's -x, I am going to also switch the signs of both of them. And let's see if I actually got it right, because I counted diagonal. Let's see if I got it right for my A prime. Is it at positive 1, negative 3? 1, 2, 3. Yes, it is. So my A prime I was able to do. Switching my T would end up being positive 2, negative 5 when I switch both of them and switch the signs. And switching my J would end up being positive 3, negative 4 when I switch them and switch the signs. So I'm going to plot these points, except for A. I've already plotted point A. So I'm going to start with S. I'm going to go to the negative 2, then negative 1, 2, 3, 4, and label that S prime. Then I'm going to plot point T, which is at positive 2, negative 5. I'm going to label that T prime. Went to the right by 2, down by 5. And then J prime is going to be 3, negative 4. So I'm going to go to the right by 1, 2, 3, and then down by 4, 1, 2, 3, 4 for J prime. When I connect these dots, it will give me that shape that flipped over and folded over that dotted line. So we're going to try one more. We're going to reflect across y equals negative 1, and that's going to be another horizontal line. Y equals is horizontal. If it is x equals, it's going to be vertical. So y equals negative 1 is right here, that horizontal line at y equals negative 1. And this time it's going to be a little bit of both. Like there's going to be some of the image that's below and some of the image that's above. So when we draw this reflected image, it's going to actually kind of look like two things are overlapped. So I'm going to start with the bottom points. We would go up by 1, so my L prime is going to be up by 1 up here. My B prime, I would go up by 2, so I got to go up by 2 more, and it'd be right here for B prime. My I went down by 1, 2, 3. I got to go down by 1, 2, 3 more for I prime. W went down by 1, 2, 3, 4. I got to go down by 1, 2, 3, 4 for that W prime. I'm going to draw this one like with a dotted line, just so that we can kind of see the original and the new shape a little bit more clearly. To see that, yes, they did reflect, but they kind of folded onto each other even more so. But that would be how you would do those. Now, the next thing that we're going to be doing is going to be figuring out what is the line of reflection. So how did it reflect? And we have to draw where it was flipped over a mirror image of. So that one requires a little bit of just visualization to see, well, did we draw the line here? If we drew that line there, would it actually fold onto itself? Or would it be here in the middle of that image? And I just drew the line of reflection because if I folded it over that line, these two things would be able to fold onto each other. So what is that line that I just drew? Well, it's a horizontal line up at 1, 2 for the y value. Horizontal lines are y equals. The y equals 2 would be the line of reflection. For number 8, the line of reflection is going to be diagonal, which is no big deal. It's this diagonal line that I'm drawing right now. So what is this diagonal line with a slope of negative 1 and a y-intercept of 0? Well, that is y equals negative x. Diagonal lines are going to be the y equals x or y equals negative x. The next two are going to be relatively simple to see. The middle of this, where it was reflected across, is right here. Well, that is going to be the x-axis. That's where we were going. You could have write or equals y equals 0, but most people would agree that it is the x-axis that this got reflected across. This one, it's actually reflected across this vertical line. So that vertical line is going to be an x equals, and it's going to be x equals whatever this vertical line is on, which is 1, 2, 3. So this is going to be reflected over that x equals negative 3. Technically, should have been putting reflected over all attached to all of these answers, but it's not that big of a deal if you understand that you were reflecting all this time. And might as well do the last two as well. This one, it is reflected right here down the middle. And that is across the y-axis, so that is where we were reflected over. Or across. I'll write across this time. Reflected across the y-axis. And number 12, the last one, if we draw this diagonal line right here, we would end up with where it was reflected across, which is actually a positive sloping diagonal line. And if it's a positive slope, then we would want to write y equals x as our reflected line. That's going to be doing it for today's episode. I'll see everybody later. Have a great day. Bye.